Alright guys, this should be a really quick set of notes. We're going to go over extrema on an interval, and when we see the word extrema, we're just thinking for the extreme points, meaning the maximum values or the minimum values, and we're always going to be talking, when we're talking about that, we're talking about the y values or the f of x values. So there are two types of extremes. There's an absolute, so we'll just say absolute maximum or absolute minimum, and like it sounds, it's the absolute highest point or the absolute lowest point on a graph or an interval. And sometimes you'll see the word global used also, like global max or global min. And the other one is going to be called a relative max or a relative min. And these are points where surrounding that point, if it's a relative max, everything surrounding the point is smaller. So just graphically, a couple examples. If we had this interval where your graph, we're starting at some point A, so that's where our interval starts, and we're ending at some point B. And our graph goes up, down, up. Actually, let's make this go a little bit higher. Okay. Now, for this case, okay, A, it's not a maximum, it's not a minimum. But then when we come over here, this point, as you can tell, it goes down to the left, it goes down to the right, so this would be a maximum. Now, it's not the very biggest point in our graph, so we call that a relative maximum. Then we come down, and this point, like we said, to the left it goes up, to the right it goes up, so this would be a relative minimum. Then up here, now it goes down to the right, down to the left, so this is another relative maximum, but it's also the highest point on our graph, so it's also an absolute maximum. And then same thing down here, this would be a relative minimum, but it's also our absolute minimum. Now, the endpoints of the graph, those two endpoints, they're not allowed to be relative maximums because there's nothing on the other side of them. That said, they are allowed to be absolute maximums. So, if we had a graph that looked like this, where we said, here's the graph of y equals x squared. Now let's say we cut it off at this point, and at this point. Okay, now point A would be our absolute maximum. It's the biggest point on our graph. And down here would be an absolute minimum, but also it's a relative minimum. Okay, and then this last point would just be kind of nothing. So, one last thing about these is, hypothetically, let's say you had something like the graph of sine x, right, comes up, goes back down, up, goes back down, and let's say we stopped it, right here. Now in this case, right, we have a relative max here, a relative minimum over here, another relative max, and another relative min. Now you might be tempted to say there's no absolute maximum and no absolute minimum, because no point's higher than everything else, but it just has to be the highest point. So actually both of these, since they're at the same value, they're both absolute maximums. So you can have more than one absolute maximum. if they're both the same value. And then similarly, on the bottom, both of these would be absolute minimums. So hopefully that kind of gives you an idea of absolute maximums and absolute minimums on an interval, right? Meaning on, some part of a graph. Interval is a section of a graph. So with that, there's kind of a theorem, and it's very obvious, but the theorem just says anytime we have a closed interval, right? So some section of a graph, and we could call it from A to B, then that graph is always going to have, so F will have an absolute maximum and an absolute minimum. That's pretty obvious, but it's just something that, it is a theorem, so I'm sharing it with you guys. Now, it doesn't necessarily have to have a relative maximum and a relative minimum, but it could. Now, there are some things called critical numbers or critical points. You'll see it both ways, but this is something that's very, very important. And some books or some problems will call it a critical number, and sometimes you'll see it called a critical point or even a critical value. But really, if you see the word critical, that's what we're thinking about. And critical points are just where basically you could have an absolute maximum or an absolute minimum. Once in a while there won't be a relative maximum or a relative minimum, the correct critical points. Once in a while that won't be the case, but really it's where the derivative is equal to 0 for the most part, and then or where the derivative doesn't exist. So what critical numbers are is when the derivative, right, f prime of x equals 0, or f prime of x does not exist. So graphically that would be, if I have a absolute value right there, that would be a critical point because the derivative does not exist. Another one where our derivative doesn't exist would be something like this. Again, that's a critical point because the derivative does not exist. Right, so that was one of the cases, derivative doesn't exist. The other case is when the derivative is equal to 0. So that's anything where we have a derivative, right there. The derivative is equal to 0. So this point is also a critical point. So anywhere we have a critical point, we don't necessarily, you're not forced to have an absolute maximum or a minimum, because if you remember the graph of y equals x cubed, right here, the graph is going to have a derivative of 0, but there's no, relative max or relative minimum. But the opposite is true. If there is a relative maximum or minimum, it has to be at a critical point. So it can't be at one of those endpoints. So relative maximum and minimums, basically, those always happen at critical points. Then, the absolute maximums and the absolute minimums, those can happen at either critical points or at the endpoints. So basically, the goal of today's lesson is going to be to find these maximum and minimums, whether they're relative maximums or absolute maximums, we want to find them. And so we're just going to do two quick examples. The first example we're going to do, I'm going to take one of the book examples because it's actually a really good example. So this is if we want to find the extrema, right, meaning maximums and minimums for f of x equals 3x to the fourth minus 4x cubed, and we want to find this on the interval -1, 2. And when we see the word extrema, right, extreme meaning like the most extreme values, extrema, I didn't go over this, but extrema is always talking about those absolute values, not the relative values yet. So we're going to learn more about the relative values in the next section. For right now, we're just going to be thinking about the extrema, which are the absolute ones. So if you were taking notes and you want to add that to your notes, absolute maximum and minimum, that's called the extrema. The relative ones are not extremas. So going back to this example, okay, you basically want to check for absolute maximum and minimums. You want to check any critical points and the endpoints. So you obviously want to see, right, critical points are where the derivative is equal to 0 and where it doesn't exist. So if you had something where you could tell the derivative is not going to exist, like 3 over x, that's not going to exist at x equals 0, right? Or something like absolute value of x, that's not going to exist. Anything where you can tell it's not going to be differentiable, then you want to think about that. But this case, it looks pretty normal. So we're just going to say for our critical points, to find those, we say f prime of x equals 0, right? We're setting that equal to 0. So f prime of x, we take the derivative, is 12x cubed minus 12x squared, and we're going to set that equal to 0. Then I'll factor out a 12x squared, and we'll get x minus 1 equals 0, and we'll be left with x equals 0 and x equals 1. So these again are my critical points, or the critical numbers. And then we want to check, like we said, we want to check the critical points and the endpoints. I usually just go in order from smallest to biggest. So I'm going to check f of -1, which is my first endpoint, then f of 0, which is one of the critical points, f of 1, my next critical point, and finally f of 2, the last one. I just go in order, smallest to biggest. You can go in any order you want. Just make sure that you check both of the endpoints and all critical points you have. Sometimes you might have 30 critical points, then you would have to check all 30 of them. Honestly, you're never going to have 30, but just to kind of exaggerate. Okay, so this is f, right? So that's the original. We're checking it in the original, not the derivative. So we're going to plug it way back here to that original f of x equals 3x to the fourth minus 4x cubed. Okay, so that's 3 times -1 to the fourth minus 4 times -1 cubed. That's going to be 3 minus -4 would be 7. Then f of 0, right, 0 minus 0 should give us 0. F of 1, 3 minus 4 is -1. And finally, f of 2, 3 times 2 to the fourth minus 4 times 2 cubed. That's going to equal 2 to the fourth, 2, 4, 8, 16, times 3 is 48, minus 4 times 8 is 32, is going to be 16. So now that we've checked every point, right? We're trying to find the extreme values, so our smallest value and our biggest value. Well, there's my smallest value, and there's my largest value, right? -1 was the smallest, 16 is the largest. So this is going to be our minimum and our maximum. Now if it asks you for the actual, coordinates, the absolute minimum would be, +1, -1, and the absolute maximum would be 2, 16. So that's really all there is to it. If you guys feel confident with that, you could just stop watching now.